Good morning, Spartans. Shout out to Cypress Lake boys and girls basketball. Both teams are in the playoffs. Congratulations. Good luck to boys basketball and girls soccer. Both teams have been tonight. Thank you to all the Solid Lake juniors and seniors who attended last night's hashtag. And thank you to Mrs. Childress for presenting the scholarship information. Way to show valor. Students, if you failed classes last semester, please do the recovery work. Either do it now for free, later, pay for it in summer school, or repeat the current grade you're in. Think about it. Students, please make sure you are masked up and you wash and sanitize your hands frequently. If you feel sick, please stay home. Remember, Friday, February 12th is a remote learning day, and Monday, February 15th is a student holiday. Thank you and have a great day.
Good morning, y'all. I'm putting in your warm up right now. So just give me like 60 seconds. Oops. Friday is the remote learning day. And then, yeah, Monday's President's Day, so no school. Okay, so your warm up is in. Go ahead and start with the warm up while I get all the other stuff in the folder that I want to do today. Okay? Oh, that's what? We're just doing the warm up right now. right, so the warm up today was basically the couple of practice questions that we did in yesterday's PowerPoint. I just wasn't convinced everybody was trying it, so I made it into a little question. So let's go over that right now. And then we'll do some practice calculations, and then I'll have you do a worksheet and maybe a little like activity. We'll see how much we have time for. Okay, I'm gonna go to the folder. No. All right, so select the following who are doing work. Choose all that apply. So pushing 1,000 Newton car 20 meters, is work being done? Yep. Lifting a rock off the ground? Yeah, because it's being lifted up, the force is up and it's moving up. Remember, the force has to be in the direction it's moving in. If you're just holding a book in your hands, are you doing work on the book? No. If you're pushing really hard against a brick wall, are you doing work on the brick wall? No, because it's not moving. When you're walking up the stairs, are you doing work on the stair? Are you doing work going up the stairs? Yes, you are. Because right, the force is basically equal to your body weight and you're lifting it up. So that one, good. Next. Choose all the following which exhibit more power. Remember, power is the rate at which we all do work. So it's work divided by time. An engine can lift an object faster. Is that more power or less power? More. That one's more power. If you take more time to push a car, is that more power? No, because remember, the faster you do something, the more power you have. If you take more time, that means you're taking longer to do something or you're using less power. You take the same amount of time to do more work. More or less. Yeah, that one's going to be more because you take the same amount of time, but maybe you do like I used the mowing the lawn example yesterday. If you take an hour to mow a lawn, well, if you take the same hour and you did 2 lawns, okay, that's more power because that's more work in the same amount of time. Same distance, same time, but more force. More or less power. Is that more? More force. If you have more force, what does that do to your work? More work. If you have more force, then you have more work. If you have more work in the same amount of time, it's more power. So that one was more power as well. Okay. All right. So first, let's do a little bit of the calculating. I didn't do too much of that yesterday. It's not too difficult, but first we do have to talk about the relationships, right? So remember, force and work. When the force increases, the work increases. So when the force goes up, the work goes up. When the force goes up, the work goes up. When force goes down, the work goes down. What kind of relation is that? Direct or inverse? Yeah, direct. That means the same thing as happening and affecting. Whatever happens to the force will happen to the work. So what happens to the work if the force is doubled? Yeah, the work is doubled. Right? What happens to the work if the force is halved? Right. Okay? And pretty simple. Not too difficult. All right, distance and work. Distance and work has the same relationship as force and work. I really like that movie they're watching next door. It like really makes me want to watch that movie right now. We started it a little bit. All right, so when the distance increases, so if you take an object and you push it further, oh, what does that do to the work? If you push it further, the distance increases, then the work is going to. And if you don't push something as far, so if the distance decreases, then the work, yeah. So it's that same direct relationship. So if you triple the distance an object is pushed, what happens to the work done on the object? Is it simple? If you quarter the distance, right, you're pushing it basically like a quarter of what it was, or it's being moved a quarter. So what happens to the work? By a quarter. Okay, power and time is one that makes sense when you think about it, or at least I always think of it as it makes sense, but then sometimes when I say if someone takes more time, you think that that will automatically mean more power. But remember that power and time don't have a direct relationship. So think of it this way, if you take more time to do something, right? If you did 20 push-ups in a minute, and then you did 20 push-ups in 2 minutes, then you doubled the amount of time. And so what would that look like if you think about it? It would be like slower. So if your time increases, the amount of time you do work in increases, what does that do to your power? Yeah. Right. And then the exact opposite. If you did 20 push-ups in 30 seconds, you'd be like, then the power would be what? Increase. Is that what you said? Did you say increase? Yeah, so that's that inverse relationship. The opposite. When one goes up, the other goes down. And it's because, remember I always told you, or I told you that one little trick that I always use? If the variable is in the denominator, that means an inverse relationship, which makes sense because if this time goes up, you're dividing by a bigger number, that's going to make this work go down. So anything that's ever in the formula in the denominator, that's an inverse relationship. If an Olympic swimmer doubles the amount of time she swims the 50 meters, and what has she done to her power? I don't even know. I haven't even my chat pulled up. I don't even know what these kids at home are doing. Hi, kids at home. So what does she do? If she doubles the amount of time she swims the 50 meters in, what has she done to her power? She's cut it in half. Yeah. So the opposite, which opposite of double is. All right, calculations. Try this one. What is the work? So you can use the markers. Y'all can throw your answers in the chat. Try this one real fast. unit. Unit. Oh, you want to get another one? Ethan. Right, so it's just force times distance, so 23 times 6. It's 138, and the unit for force is Newton, and the unit for distance is meter, so the unit is just Newton meters. All right, an object experiences a 75 Newton meters of work is moved with a 5 Newton force. What distance did the object travel? So you're looking for this. They give you work and they give you force. And so you have to solve backwards for distance. And so since it's multiplied by force, what would you do to find the work? Yeah, you would divide. So it would be work divided by force. So try this one, plug it in, solve backwards. No. So what did you just solve for? No. This. Oh, that's the. Huh? Oh, an eraser. Oh. Yeah, good job. Meters. Okay, so the work is 75 Newton meters. The force is 5 newtons, and then you're looking for the distance. So divide by 5 newtons. 75 divided by 5 is 15 meters. Do this one. Oh, power is work divided by time. Unit. Watts the unit. Watts. Technically, I think watt, like the W for work is lowercase and the W for watts is uppercase, but doesn't really matter. I'm at home. 100 joules of work, moves an object for 10 seconds. Watts, 10 watts, which is just 10. Okay, so the unit for power is watts. Oh, I want to do one more. Hold on. We can keep those. I can save that as notes. Let's insert. New slide. Okay. Let me pick a design. Wind and air. So how would you do this one? Huh? So it's kind of like a two-step problem. You good? Okay. So power is work over time. And so for this one, they don't give you the work, but you know how to calculate work. So it's kind of like a a two-step problem, not a three-step problem. But sometimes you'll even just see, right, work is force times distance and then divided by the time. And so you can just insert the formula for work here on top. So force is 26, the distance is 10, and the time is 3 seconds. Yeah, so when you're done, you get 86.7. And what's the unit for power? Okay, All right, so I have practice calculations for you that you can do. I guess I'll go ahead and assign that. I have another little lab activity that I wanted you to do too. But I can assign that for tomorrow. Maybe that would be a better idea. Unless you feel like doing push-ups and running up the stairs today. Okay, I won't laugh like that again either. Okay, so this is it. It's just a practice. And honestly, I think I stole a couple, like number 2 we did. Yeah, so we'll do this little practice worksheet today. So let me put this in your folder. Assignment. And power practice. I'm not entirely too sure if I'm going to grade this. I might not. Can't tell you right now. So just practice. So all right, guys, so it's in your folder, and I will add a separate page that has the formulas. Okay, do y'all have any questions? Okay, well, if you do, I'm here. I'm going to mute myself to get the face-to-face kids started, but I'm right here. right, guys, you have a good rest of the day. I'll see y'all tomorrow.